So in this section we will see what is active learning. So active learning is a special case of semi-supervised machine learning in which the learning algorithm is able to query the user to obtain the desired outputs at new data points. So in active learning, what we are doing, we are querying the user so that the desired outputs can be obtained very accurately. And as we are directly querying the users, it is more interactive, and that's why this type of machine learning is called as active learning. So it is sometimes also called as optimal experimental design when it is related to statistics. Why it is optimal experimental design? Because we are directly interacting with the user, and as we are directly interacting with the user, we are by providing the query, we are directly having the output or desires of the user, and so that it is very easy for us to do all the experimentation. That's why the optimal experimental design is also name of active learning. So there are situations in which the unlabeled data is abundant, but manual labeling is expensive. So in such scenario, learning algorithms can actively query the user for labels, because we are not having labels. So in this, the learning algorithm will query the user for labels. So this type of iterative supervised learning is called as active learning, because the learner chooses the number of examples to learn the concept and to behave in a normal supervised learning mode. And by this approach, there is a risk that we will have uninformative examples as well. But recent developments are dedicated to multi-level active learning, that is hybrid active learning in single pass context, which combines the concept from the fields of machine learning, that is conflict and ignorance, with adaptive incremental policies and on. So we are having T as the data set, and that is broken into three subsets. So the first one where the data points are known, the second one where the data points and label is unknown, and the third where the data points are chosen and labeled. So the first one is TKI, that is data points where label is known. Second one is TUI, where data points where label is unknown, and third is TCI, that is subset of TU is chosen and unlabeled. So these are the three types of data subsets that are taken from the main data set. Then the query strategies that are used for the active learning. So the algorithms for determining which data points should be labeled can be organized into various number of categories. So uncertainty sampling, label those points for which the current model is least certain, so the output should be what the correct output should be. So the first is query by committee. So variety of models are trained on the current labeled data and vote on the output for unlabeled data. So what we are doing, the number of models are trained. As I said, when we are talking about active learning, before querying, the various models are trained, and only after studying that models, the queries has been asked. So the variety of models are trained on the current labeled data and vote on the output for unlabeled data. So the training is done on the labeled data, and then the voting for the output unlabeled data is done. So label those committee points for which the committee disagrees the most, that labeling has been done by query by committee. Then the second is expected model change. So label those points what would be most change the current model. So in this, we have to label the points which can change the current model. Then the third one is expected error reduction. Label those points that would reduce the model's generalization error, and label the points that would minimize the output variance, which is one of the components of error. So what we are doing in expected error reduction, we are labeling the points that can reduce the generalization error, so that the minimum error we will have, and that will reduce the minimization output variance, because this is one of the component of error. Then balance exploration and exploitation. So the choice of examples to label is seen as dilemma between exploration and exploitation over the data space representation. Now there is the choice of examples are there, and there is a dilemma that what should be used, exploration or exploitation, when we are talking about data space representation. So the strategy manages the compromise by modeling the active learning problem as a context banded problem. Means, for example, we are proposing the sequential algorithm, then in each round we are assigning the sampling distribution on the pool, and then we are sampling one point from the distribution and then queries for the sample point label. And the exponentiated gradient exploration for active learning, that is wide variety of algorithms falls in these categories, by using which we can have the interactive session with all the users. So this is all about active learning and the query strategies that are used in active learning. In our next section we will see the graphical model and the types of graphical model. Thank you.